All right, so we're looking at review exercises on page 755. And these are again for chapter 10. And now we want to do something that would have been on 10.4 material, which is conics. So all right. I'm going to take a look at 43. So the instructions are, so first of all, they give us the following equation: 4x squared plus 8y squared equals 16. And the instructions are, starting with A, to determine whether the following describe a parabola, an ellipse, or a hyperbola. So parabola, ellipse, hyperbola. So looking at this, what do you guys think?
And ellipses?
Ellipse?
Yeah, I'm noticing two x and y are squared, so it's probably between ellipse and hyperbola.
Good, because with a parabola, one variable is squared and the other one is not, like y equals x squared, so that's a good place to begin. And then why would you choose an ellipse over a hyperbola?
Because you're adding, not subtracting.
That's perfect. So with an ellipse, we have x squared over a squared plus y squared over b squared. And with a hyperbola, we have x squared over a squared minus y squared over b squared. Or the variables may be switched, but you do have a difference. So absolutely correct. So the correct conclusion here is that this is an ellipse. And I'm sure we're going to do more with it in the next parts. So let's see how we're going to work with this. But the first part I just said identify. So then part B. 43. There it is. Use analytical methods to determine the location of the foci, vertices, and directrices, if there were any. But in this case, we don't have any directrix. That's for parabola. So we want the foci and vertices of this ellipse. So I'm going to put find foci and vertices. All right, so to do that, we would like to get an idea of where this parabola is, what the A and the B are in our picture, all that good stuff. So the way to do that is to get it in the proper format, which it did not come in. So as we did once before on Monday, I would get my 1 on the right by basically dividing everything by 16. So if I do that, I'm going to get x squared over 4 plus y squared over 2 equals 1. So now we can see it more properly in the format of an equation for an ellipse. And we know that the 4 is the a squared and the 2 is the b squared. We can see this is centered at the origin. It's probably going to make us graph it anyway. I didn't look at the rest of the problem. So A is 2, so I'm going to go out 4 spaces here. 1, 2, 3, 4, and say that that's where 2 is on my scale. Minus 2. Okay, and the B is the square root of 2, which is like 1.4, something like that. So we're going to get something like this. So we want to identify the ellipses and the foci. So first of all, the ellipses, I'm sorry, not the ellipses, the vertices. So the vertices I can get, and they probably just want the major vertices, but I'm going to put them both up. So major vertices are at plus or minus 2 and 0. That's 2 points given there. And then the minor vertices are at 0 plus or minus the square root of 2. So then we need to also find out the foci. So for the foci, we want to remember that the relationship, the Pythagorean relationship, is that a squared is equal to b squared plus c squared. Oh, it's hard to write without putting my hand on this. A squared is 4. B squared is 2. So that gives us that c is equal to square root of 2. So that means my foci are square root of 2 to the right and square root of 2 to the left in my picture. And so that means I can identify those as plus or minus the square root of 2, 0. I would have normally just given you time to go through and do all of that yourself, but yeah, I'm trying to get a couple of problems in and we don't have a lot of time left, so doing a little bit more of it for you. But are there any questions, comments, discussion about how I found the foci, vertices of this ellipse?
So we know that it's centered at the origin because there's no like shift in x and y. Like it's just x.
Yeah, and what I ended up figuring out, which I wasn't as clear about when I did the first half of our class on Monday, by the time I did the second half, is it looks like the chapter never goes there. But in this book, they just don't want to add the complexity of like an HK off-center place, which you normally do in pre-calculus. So I think probably all the problems are going to be centered at the origin.
Sounds good.
So part D says make an accurate graph of the curve. So I'm going to say that sketch that I just made is accurate. So then that's part D. But let's take a look at part C.
Quick question, just a quick
Yeah.
question, just to make sure I got this correct. To find the foci, you do a squared equals b squared plus c squared?
Correct. So for an
Okay.
ellipse, the A value is the biggest of the three.
Mm-hmm.
So it's the Pythagorean relationship, but the A squared is equal to the sum of the other two. For a hyperbola, the C value is the bigger of the three. So then you'd have C squared is equal to A squared plus B squared. And those are the two to keep straight. The hyperbola, the C is the big one, and in the ellipse, the A is the big one.
Gotcha. Okay, thank you.
Okay, so we didn't really talk about it last time, but let's just see what the formula would tell us to do. For part C, it says find the eccentricity of the curve. So let's see if we can at least spend a couple of minutes on that so we can look at the definition of that together and see if we could apply it. Where's my page? Pass right by that. Okay.
Professor.
Yeah.
Yeah. For part B, it says as well as foci and vertices. It says directrices. Yeah. Could you recap probably what the directrices is?
Yeah. So at the beginning, I wrote when we got to that part, I said that an ellipse doesn't have any directrix. Directrices is the plural of directrix, and that's because there's more than one problem they're referring to, and there might be more than one parabola. So if we had a parabola, then we would be identifying the directrix for that parabola. But
Okay.
since we don't have a parabola, we don't have anything to identify for this problem. Does that make sense?
Oh yeah. All right. Yeah.
Yeah. So they were talking about a batch of problems, and some of them will be parabolas, and for those, you would be giving the directrix. Now it's interesting, they didn't ask for the equations for the asymptotes, which is usually the other thing they would ask for if you happen to have a hyperbola instead of, a graph or something, one of the other graphs. But nonetheless, the vertices is shared by all of them. Having focal points, one or more, are shared by all of them. Directrix is only for a parabola, and asymptotes are only for hyperbolas. And major and minor axes, only both of those are in an ellipse. Okay. guess is one of the ways to think of it. Okay, how are we doing? Yeah, like 13 minutes left. Okay, so yeah, I'm gonna, again, we could look at the eccentricity, but I think until people are really warmed up with this, it would take the rest of our time. I'd rather do an example the other way. So I'm gonna skip that for now. And again, if you have questions, come see me in office hours tomorrow if you're still working on that. But I don't think it's beneficial for the class for me to go down that rabbit hole today to finish today's class. Let's instead try to do another example where we have to go in the other direction. So in this direction, we were given the equation and we had to come up with information about the graph, like vertices, foci, things of that nature. And so it's important to be able to go in the other direction. So let me do one of those to make sure that that is done. I just lost it. There it was. So they have a further batch of problems. So let's clear this. All right, so maybe let's grab, oh, that's a matching problem, tangent lines. In this batch, I don't see one that goes directly back the other direction. So I think I will go back then, because I definitely want to make sure that people see that's the other direction of the skill that we want. They have you match a bunch of graphs, which is kind of the same thing, but harder for us to do as an example. So instead, let's turn to page 750, where we have 10.4 review exercises. And maybe let's try 36. Okay, so 36, it says, find an equation of the following ellipse, assuming the centers at the origin, sketch a graph labeling the vertices and the foci. So in this case, they're telling us about the ellipse and we're supposed to come up with the equation, which is the reverse of what we just did. So in 36, it has an ellipse, and they could do the same thing with a hyperbola or a parabola as well. But this one is an ellipse with vertices at 0 plus or minus 10. And it says passing through a point. We didn't do one of those before. And the point is square root of 320, square root of 3 over 2, 5. So we're supposed to find an equation and sketch a graph, labeling the vertices and the foci. So we need to also come up with the foci. So we need to come up with the foci, we need to come up with the equation, and they gave us the ellipse, the vertices and a point on the ellipses, on the ellipse. Okay, so how are we doing? Like 9 minutes. All right, so I'm just gonna sketch this somewhat quickly. Okay, so what do we know? Vertices at 10 and negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, okay. There. Oh, I totally got it wrong already. So 10 is in the Y spot, not the X spot. So I got to back that up. And I'm going to change the scale of my graph. So let's say this is at 10. We've got a point up here, 0, 10. And at negative 10. So they're saying vertices, and they're not saying minor vertices. So as I said in this book, that means they're talking about major vertices. So they're thinking this is a parabola that has wider in the up and down direction than in the side to side direction in some way. So that means that this tells us that this is our A value. And it goes through the point square root of 3 over 2, 5. So square root of 3 over 2 is a little less than 1. And 5 would be about 2.5 there, halfway over. So it's like something around here is a point. So 5 square root of 3 over 2. Maybe there. Something like that. So that is a pretty skinny looking ellipse, I think. So let's zoom this in a little bit. This point is like something like there. Okay. Yeah. Okay, so we know that we want to form an equation. So it's something of the form, well, in this case, since it's bigger in the y direction, I'm going to write y squared over a squared plus x squared over b squared equals 1, where I know that a is the semi-major axis length. And in this case, I know that that's 10. Because I know that the vertices on the major axis go up and down 10. So that means that down here we have 10 squared. So that tells me I have y squared over 100 plus x squared over b squared equals 1. So I need to figure out b, because then I can draw in the ellipse by sketching out the minor axis, the right to left axis. And I also need to figure out b, because with a and b, I can figure out c and say where the foci are, which is the goals of this problem in the remaining 6 minutes. All right, so what I have to do is I have to use the point they gave me that I know is on the graph. That means it satisfies the equation, and substitute those values in for x and y, and then I'll have an equation with only b squared in it, and I can solve for b. Okay, so if I plug in those values, so y is a 5, so that gives me that 5 squared over 100 over root 3 over 2 squared over b squared equals 1. So that gives me 25 over 100, which is 1/4. And this gives me 3/4 divided by b squared, which is 3 over 4b squared equals 1. So I'm going to multiply everything by 4b squared to kill off those nasty fractions. So I get b squared plus 3 equals 4b squared. And that's going to give me that b equals 1. That seems a little nice. Yeah. So if b equals 1, then my equation, which one of the things they wanted, is y squared over 100 plus x squared over 1 squared, so I'm just going to write x squared, equals 1. So there's my equation for the ellipse. And I know that the b direction is 1, so that's here on my graph. Well, not even really there. And that was supposed to be less, so I'm just going to leave the scale there. So I have kind of a long up and down skinny ellipse, goes to that point. And so the point here, so then there's foci, and the foci are going to be somewhere inside on the y-axis. But to figure that out, I need to find the c value. And I know that c squared equals a squared plus b squared, which is 101. So that means c equals, except I just messed that up. I'm using a hyperbola instead of an ellipse. A is the big one. Let's try that again. Catch myself if I can. So a squared, which is 100, equals b squared plus c squared. So c equals the square root of 99, or 3 root 11. So these foci are going to be at 0 plus or minus 3 root 11. So again, just to make sure I've met the conditions that it asked for, so it said find the equation of the ellipse, which we have there. Assume the centers of the origin, sketch the graph labeling the vertices and foci, which I have there. So that's it. So 2 minutes. Questions, comments, discussions? Sorry that that's a bit rushed. I was trying to make sure we finished before class ended. Any questions about how I took the information provided, which was a point on the ellipse and the vertices, and came up with its equation and the location of the minor vertices as well as the foci? Any questions about any part of that?
So we took one particular point where it was passing through that satisfies the ellipse to find our b value.
Correct. So basically they gave us, to have a function, you kind of need two pieces of information. I mean, go back to a line. For a line, you need a point and a slope. So for parabolas, it gets a little bit more complicated, but it's pretty close to similar. But when you have a two-dimensional shape, you kind of sort of need enough information about it to fill in the details. Well, for an ellipse, once you know it's the shape of an ellipse, the only thing you don't know is A and B. So they could just tell you those directly. They could have told you those by saying, what the vertices are and what the minor vertices are. So then you'd know A and B. But they dodged that by telling you one of those. They told you the vertices, which gave you the A value. And then instead of telling you B, they told you one of the points on the curve. So then by using that, you can also find B. Does that make sense?
Yeah, that makes sense.
Other questions, comments, discussions in our, I guess the time has just clicked away for the class, but before I erase this and move on to just general office hour issues, any questions about the math in 10 before we finish up the session today?
Yeah, I have one question.
Yes, sir.
I think it's just to clarify. So the foci will always be along the major axes, is that right?
Correct.
Oh, always, right?
Always. Yeah. That's what makes it wider one way than the other.
Oh, okay then. And then it's just gonna be like, well, the point that's not zero, it would be just the C, I guess, right? So the foci is just one of the either X or Y coordinate 0, and then the other one would be, well, square root of A square plus B square. Wait, A square minus B square, right?
Correct. And they actually give the formula that way in the book.
Oh, okay then.
Yeah. And remember, so the C is what we call the focal length, the distance from the center out to the foci along the major axis.
Oh, all right.
Yeah. You got it, Timothy.